If two sound sources of a slightly different frequency, for example, frequencies N1 and N2, if they interfere, then what will happen? Amplitude will vary. There will be variation in the amplitude. See, amplitude will vary like this one, and frequency will become average of these two. Frequency of oscillation become average of these two, and there will be variation in the amplitude. And if you see this one mathematically, let's say first sound wave is y1 is equal to a sine 2 pi n1 into t, and y2 is equal to a sine 2 pi n2 into t. If they interfere, so y should be equal to y1 plus y2, and if I add these two things, so a sine 2 pi n1 t plus sine 2 pi n2t. Now this one we can expand using sin c plus sin d formula. And what's the sin c plus sin d formula? Sin c plus sin d is equal to, we can write sin c plus sin d is equal to 2 sin c plus d divided by 2 into cos c minus d divided by 2. So using this formula, if I expand this one, so finally what I'll get, y is equal to 2a cos 2 pi n1 minus n2 divided by 2 into t into sine 2 pi n1 plus n2 divided by 2 into t. And we can see this is the frequency. This whole thing is the frequency. Basically coefficient of t is frequency. So this term contains frequency, and this remaining term contain amplitude. So this is r, amplitude. This whole thing is amplitude. Right. So this 2a cos 2 pi n1 minus n2 divided by 2, this is the amplitude. We can say it's r. And if I need r maximum, in that case what should I have? Cos 2 pi n1 minus n2 by 2 into t, that should be equal to plus minus 1. This is for maximum value of this one. It means 2 pi n1 minus n2 divided by 2 into t, that should be equal to cos n pi. And if I solve this one, so after solving, what I'll get, n pi, and I'm writing this one capital N, and n can be the whole number 0 1 2 3 4 5 6. So if I solve this whole thing, I will get t is equal to n divided by n1 minus n2. So if I put n is equal to 0, so I will get value 0. If I put n is equal to 1, value will be 1 divided by n1 minus n2. If I put n is equal to 2, 2 divided by n1 minus n2. n is equal to 3, 3 divided by n1 minus n2. So if I take difference of this consecutive two terms, so that will be 1 by n1 minus n2, and this is the time period of a two frequencies, and 1 upon time period, if I write 1 upon t, that should be equal to n1 minus n2. So this is called beat frequency. So beat frequency means simply difference between two frequencies. So beat frequency is equal to n1 minus n2. Better I write mod value of this one, because anyone can be bigger or smaller. So whenever we have to calculate beat frequency, so there should be mod of n1 minus n. Based on this one, if we solve some numericals that bring a more clarity. For example, there are two identical sonometer wire have a fundamental frequency 500 Hz and kept in the same tension. What fractional increase in tension one wire would cause on occurrence of 5 beat per second when both wire vibrate together? So here beat frequency is 5 beat, and they are asking fractional increase of frequency, means they are asking n naught dash minus n naught divided by n naught. This value they are asking. So if I write n naught value, so n naught should be equal to 1 divided by 2L under root T by mu. This is the frequency formula. And after increasing tension, n naught dash, that should be equal to 1 upon 2L under root T plus delta T divided by mu. Delta T is increase in the tension. So if I solve this whole thing, so I will get n dash is equal to n naught under root 1 plus delta T by T. And using binomial expansion, if I multiply 1 by 2, so I will get n naught dash is equal to n naught 1 plus 1 by 2 delta t by t. And using binomial expansion, we got this formula. Then what we do, just we can write, just simplify this formula. I'll write n naught dash minus n naught divided by n naught. This value will be equal to 1 by 2 delta t by t. They're asking for delta t by t. So what we'll do, we can write 2 times delta t by t is equal to 2 times of n naught dash minus n naught divided by n naught. This will be answer. N naught dash minus n naught, that is 500. So 2 into 5, not 500, 5, and this n naught is 500. So if I substitute this value, so I will get final answer 0.02. So this is the fractional tension, not in temperature. So based on this one, there is a one other numerical. Two wires are there, two tuning forks are there. Based on this one, there is another numerical. A tuning fork of frequency 300 Hz resonate with air column close at one end at 27 degrees Celsius. How many beats will be heard in the vibration of the tuning fork at column 0 degrees Celsius? Or इसमें end correction you should not take. End correction is negligible. So we can write here n is equal to V divided by 4L, and that is given to us. N is equal to V divided by 4L, that is 300 Hertz. It's a given for one end fixed air column. Now when temperature increases, so we can write V directly proportional to root of T, that is velocity formula. It means V naught divided by V2, that should be equal to 273 plus 27 plus 273, that should be equal to 0.954. Now V naught will be equal to 0.954 into V2. This is the value of V naught. Now n dash should be equal to V naught by 4L, because velocity become 4L, V naught, so V naught by 4L. And what's the value of V naught? V naught value is 0.954 into V2 divided by 4L, and V2 value you already calculated 300. So 0.954 into 300 divided by 4L, and after calculation we'll get this one 286. And if they're asking for beat frequency, obviously they're asking how many beats should be heard. So initially it was 300, now it's a 286. So how many beats will be there? 14 beats will be heard. Okay, next question. A string under tension 129.6 Newton produce 10 beat per second when it's vibrate along a tuning fork, right? When the tension in the string increase 160 Newton, is sound in unison. Unison means same frequency. Frequency will become same with the same tuning fork. Calculate the fundamental frequency of a tuning fork. So initially, how many beats will be there? 10 beats are there. It means n minus 20 should be equal to 1 by 2L. This is the frequency formula, 129.6 divided by mu. Second, n is equal to 1 by 2L under root 160 divided by mu. If I solve this whole things, I will get n minus 10 divided by n, just dividing equation number 1 and equation number 2. If I divide these two, so I'll get under root 129.6 divided by 160, and after solving this one we'll get n is equal to 100 Hertz. Okay, two tuning forks A and B, when sounded together produce 4 beats, means frequency difference is 4 beats. Tuning fork A is unison with 30 cm long sonometer wire, and B is unison with 25 cm long wire, same tension. Calculate the frequency of the tuning fork. So we know frequency directly proportional to 1 by L. It means NA divided by NB is equal to LB divided by LA. So that will be equal to 25 divided by 30. That will be equal to 5 by 6. It means NA is equal to 5 by 6 times of NB. Right. Now difference between NA and NB, that should be equal to 4. Either this formula is right, or else we can write NB minus NA is equal to 4. Second one is right. First one will be right if NA is greater than NV. Second will be right if NV is greater than NA. Now we have to check which one is greater. So if you look at this one, obviously NV is greater. Why? Because NA divided by NV, that is equal to 5 divided by 6. It means that NB is greater than NA. So which formula I should use? NB minus NA, that should be equal to 4. Now using this equation number A and equation number B. And if I solve these two, so what I'll get here, Na is equal to, if I solve equation number 1 and 2, so in place of Na, what I can write 5 by 6 Nv. So Nv minus 5 by 6 Nv, that should be equal to 4. Here Nb divided by 6 is equal to Nb divided by 6, that should be equal to 4. It means Nb is equal to 24. So if I got Nb is equal to 24, so Na should be equal to 20. I can substitute value in this equation and I will get Na is equal to 20 Hertz. So final answer, Na 20 Hertz and Neb will be 24 Hertz. A air column at 51 degrees Celsius and tuning for produce 4 beat per second when they sounded together. Okay, as the temperature of the air column decrease, the number of beats per second tends to decrease, and when temperature is 16 degrees Celsius, the two produce 1 beat per second. To find the frequency of tuning fork. So we know this is the formula for frequency. V is equal to N is equal to, we know formula for frequency N is equal to, that is V by 12. Now N1 divided by N2 is equal to under root T1 divided by T2, because V directly proportional to root T, that's why frequency also directly proportional to root T. So N1 divided by N2 is equal to T1 by T2. So what I can write N1 by N2 from this one, so N1 by N2, that will be equal to T1 by T2, means 51 plus 273 divided by 16 plus 273. So if I solve this whole things, I will get N1 divided by N2, that is equal to 1.059. 1.059. This is N1 by N2. It shows that N2 is smaller and N1 is greater, means N1 is greater than N2. If ratio of N1 and N2 is greater than 1, it means N1 is greater and N2 is smaller. So N1 is greater than N2. So N1 should be equal to N plus 4 and N2 should be equal to N plus 1, because we know N1 is greater than N2. So N1 should be equal to N plus 4, because 4 bits are heard, and N2 4 bits are heard, and N2 1 bit heard. So N2 is equal to N1 plus 1 bit per second. So what is the ratio of these two? So if I solve this ratio of these two, N plus 4, just substitute value of N2 and N1. So N plus 4 divided by N plus 1, that is equal to 1.059, and after solving this one, I will get N is equal to 49.8 Hertz. So this is the frequency.